Hey, sixth grade, welcome to the fourth and a half and final lesson of Chapter 3. Today we've got 3.4 extension, which is titled Factoring Expressions. Okay, Chapter 3 is still algebraic expressions and properties. And our learning target for today is I can use the distributive property to produce equivalent expressions. All right, and we'll start with our key idea and how to factor an expression. It says, writing a numerical expression or algebraic expression as a product of factors is called factoring the expression. You can use the distributive property to factor expressions. So I really like to think of factoring an expression as kind of like the opposite of using the distributive property. You kind of are almost undoing the distributive property, if you will. It's kind of tricky to explain, but I think you'll see after a few examples how it relates to the distributive property, just like it says in our learning target, okay? So if you look at this example, it says 3 times 7 plus 3 times 2 is equal to 3 times 7 plus 2. Okay, last section we went from this statement to this algebraic expression, and then we solved it. We're kind of doing that backwards in this section. So it's kind of almost undoing the distributive property, if you will, in a way. So let's try it. It says, for example 1, factor a numerical expression using the GCF. Remember, GCF stands for the greatest common factor. So we'll find the factors of 12 and the factors of 20. Remember, factors are numbers that multiply to get to that number. So I like to start with 1 and itself, so 1 and 12. 1 times 12 is 12. It's even, so 2 times 6 is 12. And lastly, I'd have 3 times 4 is 12. Okay, and the factors of 20, I've got 1 times 20. It's even, so 2 times 10. And then I have 4 times 5. 6, no, 7, no, 8, no, 9, no, 10 I already have. So there's my factors. Which of these is the greatest that they have in common? 1, 2, 4, and none bigger than that. So 4 would be my greatest common factor of 20 and 12. Okay, so that is what I'm going to take out of this numerical expression. I'm going to take out 4. Okay, and then I'm going to see what I'm left with. Okay, so in other words, if I were to take 4, oh, this keeps erasing. If I were to divide 20 by 4, because remember when we're using the distributive property, we're saying this times this is equal to what's inside the parentheses. So to undo that, I need to divide my expression by my greatest common factor. So 20 divided by 4 would give me 5. I'm subtracting. And 12 divided by 4 would give me 3. Okay, so that's kind of, so this is the answer. This is the expression factored out. It's kind of, like I said, reworking it backwards. So if it helps, leave yourself a note of how we did this. So divide D-I-V-I-D-E, expression by the GCF. Okay, divided this expression by its greatest common factor of 4. So 20 divided by 4 is 5, and 12 divided by 4 is 3. Okay, let's try another one. And this time it says, which expression is not equivalent to 16x plus 24? Okay, so let's go ahead and factor this like we did the last problem, and see what is the GCF of 16 and 24. Well, factors of 16 would be 1 times 16, 2 times 8, and 4 times 4. And factors of 24 would be 1 times 24, 2 times 12, 4 times 6, and, oops, I forgot, 3 times 8. Okay? The greatest common that they have between them is 8. So I'm going to factor out 8 from this expression right here, because 8 is what they have in common. Right? I'm going to factor out 8. Okay? So if I were to do that, I would come up with 16x divided by 8 would give me 2x, plus 24 divided by 8 would be 3. Okay? So in this example, which of these match up with one? Well, okay, if I took, that looks like letter D, 2x plus 3 times 8, great. So that would work, but the question asks which is not equivalent. Okay, well, let's go ahead and distribute my other problems to see if they are equal. Well, 2 times 8x would be 16x, and 2 times 12 would be 24, plus 24. Oh, that's the same thing as my original one, so it can't be that, because that does work. Letter B, let's try as well. 4 times 4x gives me 16x, plus 4 times 6 is 24. You'll see this is also the same, so that can't work. Letter C has to be it. If I take 6 and multiply it by 3x, that give me 18x. Definitely not 16x. Okay, so that one would not be equivalent. You'll see when they factored for A, B, and D, they took other factors out that were common. So in this one, they took 2 out, and B, they took 4 out. They were common, but they weren't the greatest common factor like we did at first. Okay, so the expression that's not equivalent would be letter C. All right, lastly, with example 3, it says you receive a discount on each book you buy for your electronic reader. Okay, so this is kind of like a Kindle Fire or an iPad or something along those lines. The original price of each book is X dollars. You buy 5 books for a total of 5x minus $15. Factor the expression, and what can you conclude about the discount? Okay, so we're going to factor this expression, 5x minus 15. All right, well, ask yourself, what do they have in common? What is their greatest common factor of 5 and 15? Well, it's actually 5 itself. One of the factors is greatest. So I'm going to take out 5. Well, if I took 5x and I divided it by 5, I'd just be left with x. And if I took out, if I divided 15 by 5, I'd be left with 3. So I'm going to subtract 3. There is my factored out expression. What can you conclude about it? Well, what we can conclude is this minus 3 represents the discount you get on every book. Okay, my timer had ran down there, but I just want to explain this a little bit more to make sure you understand it. So it says, what can you conclude about the discount? Well, in this expression, 5x or 5 times x minus 3, what does that represent? Well, that represents that we bought 5 books. You see that right here in the expression. And the x minus 3 represents the price of each book. And why is it minus $3? Well, here it talks about you get a discount on each book you buy for your electronic reader. Okay, so a discount obviously is when something is cheaper. So that's what's represented by the x minus 3. Okay, so the factored expression shows this discount of $3 for every book you buy. And the original expression right here, 5x minus 15, shows a total savings of $15, right? If you bought 5 books and you got $3 off each one, that would give you the discount of $15 total. All right, since this is an extension, there's not a whole lot of practice. You can find it on page 141. I think I say that on your self-paced sheet as well. But let me know if you have questions on the practice, and good luck. And until next time, we'll talk to you later.